GCP last night decided to update the kernel on all of their GCP nodes and wiped our custom kernel. And we should have just disabled that in our Terraform, but we didn't. So, good bug to catch. So we'll only be migrating between AWS instances, but I think that's good enough.
That's good enough.
Today. Yeah.
That's good enough. It's a good story to start with. So the demo was supposed to include GCP.
Yes.
And the reason why we can't demo GCP is because they ran an update that wiped the custom kernel, which is temporarily needed. What's the feature that you need in the custom kernel?
KVM. Virtualization.
I see. That's a pretty important one.
Yes.
Okay, I see.
So we have a couple hundred migrations that are happening in the background here. You can ignore some of these disconnects. They're quite literally due to the fact that I am SSH'd into over Wi-Fi. So for the demo today, we usually do this demo in like a terminal, and it's not very easy to figure out what's happening at any given point in time. So what we've done is we've created these dashboards that are quite literally just pinging our API and getting the current state of things. So I'll start with the top left one. This one is showing the two workers that are connecting. It's not showing the GCP workers, just the AWS workers. And it's showing where the VM is running at any given time. And so you can see it's running on AWS 1, and then every few seconds it jumps to AWS 2, and then it's coming back to AWS 1, and it's coming back to AWS 2. And so it's just quite literally bouncing back and forth.
Oh, wow. Okay.
And so this is happening like live in real time. You can see the shell script that's calling the migration on the bottom right here. And so you can see it waits for 3 seconds, and then it does another one. And then it waits for 3 seconds, and it does another one. And you can also see that we're like not throttling the VM. We don't have to. This is running Postgres as well. Specifically, I thought it would be interesting if we ran Postgres.
Yeah, that's so hang on. Postgres is live migrating every few seconds, every 3 seconds.
Yes.
Between two machines.
Yes. Without losing its disk state, without losing its in-memory state, any in-progress transactions, etc., etc.
Okay.
Yeah. On the bottom left here, we're hooked into Loophole's network plane, and we're watching the network connections to these instances as they move. And so you can see that a new connection is getting created every second or so. We're doing this on purpose to validate that new connections work as well as old connections work. We have the timeout set to be very, very tight right now. And we've done that on purpose so that we can figure out, this is actually technically our integration test script. So we do this to make sure that any changes we've made are working as expected. And so you can see we're making a bunch of connections. All the existing connections are still connected, which is important. And we're connecting to Postgres in this case.
Right.
And then on the top right here, we have a single PSQL client. And so you can see that it's using the set commands. So it's doing a write on Postgres. And then this I can show this later. This set command creates the table if it doesn't exist, and then also writes a random value into the Postgres table, like into a row that it just creates. And then the get command is consistently getting that value and validating that the state is exactly what we expect. The value that we are writing is what worker we are on, as well as and you can see we're also writing some timestamp as well. Yeah. And so that allows us to validate that everything is like the state is being maintained. It's also how we're building this migration history. So we're just looking at the values as they're changing and saying, oh, okay, I know which one I was on, right?
Yeah.
And we use this to figure out exactly, where the bugs are, if there are any. In this case, there aren't, thankfully, because all the kernels are correct. We're also able to test a lot of different values that we want to see. So, for example, if we're migrating between AWS and GCP and we know that the network latency might be a little bit higher, we can do things like enable dynamic throttling if we need to for like a larger instance type. And so, the nice thing here is that this specific end-to-end demo kind of shows that all the connections are maintained, which is really good, even though we're moving. But then the really cool thing, which you might not see, is if you look at the Postgres command, you'll notice that we're always connecting to the exact same IP, which is not the case if you're migrating normally with the VM. So that's kind of how we know that our network plane is in the middle here. Our network plane is doing that natting magic that I was telling you about, so that even though we're making the exact same Postgres, or in this case, we're actually not making a new request. We're asking it to reuse the same connection. But even if we were, right, because it's always connecting to the same IP, the client doesn't know. It can't tell. But we're not using a custom psql. We're also not using a custom Postgres to make this work, right? We're, in fact, what we've done is we're running the official Postgres OCI image. And I'll just do what I'll do here. So you can see that we have all of these different options that we use for testing to validate that, everything's working as expected. Sometimes we use S3, sometimes the S3 writes have to be concurrent, sometimes they don't. But the really cool part is that we are just using quite literally the off-the-shelf Postgres
That's really cool.
OCI image. So what we're doing is we're running it inside like a run C shim. Directly in the VM. And so it's getting all of the resources that it normally would, but it means we don't have to make, customers don't have to build custom VMs. They can just bring us an OCI image and tell us the port, right? Like we do need the port as well. But as long as they give us those two pieces of information, we can kind of set this up and have it migrate very quickly. Obviously, these are within the same VPC. So like that's a little bit easier in terms of migrations. Yeah. I really wanted to show multi-cloud just to kind of show, because the cool thing about multi-cloud, and really the reason that we couldn't have done this demo with metal instances is that the CPU types are different between the two cloud providers. Yes. And so the question is, how do I live migrate? Because a snapshot in VM is in essence a snapshot of many things, including the program counter, the bytecode, like that's currently being fed into these virtual processors. If you change the underlying CPU and you're not careful about it, it breaks, it doesn't resume, right? That's why snapshots in general are not portable, or they're not considered portable, even between instances, let alone between cloud providers, right? And so one of the things that our custom kernel does, on top of just enabling nested virtualization in the first place, is it explicitly goes and it normalizes the virtual environment between the different instance types, so that the VM is able to resume, even between different CPU families, CPU generations.
That makes sense. Yeah, that's really cool. I'm wondering what happens if you were to restart one of the VMs, one of the EC2 hosts.
While this was running?
While this is running, yes.
Okay. I'll have to time it correctly because this integration environment isn't set up to like respond to that event that way. But normally speaking, with spot instances, we get that nice 2-minute warning. Okay. If you don't give us the 2-minute warning, what you'll notice is on both hosts here, there's this package, there's this blueprint, and then there's the running instance in blue.
Yeah.
Okay. This package is a snapshot of the VM. This is the part that's getting synchronized in the background, right? And so this is, in this case, just the memory. There's also the disk being done in the background. We're not showing that here because the disk state doesn't really matter as much. It's mostly the VM's memory state that we really need to be tight on keeping it synchronized. But what would happen is architect under the hood would notice that a worker was gone, and it would attempt to find the latest snapshot, which it would in this case, and it would just start from that snapshot. And so this snapshot in this case would be at maximum 3 seconds behind, because that's how fast we're triggering these migrations. But that's generally kind of how you can expect architect to work. So in the event that a host completely disappears from the world with no warning, and you can tune this number, obviously, you can guarantee the last kind of time that we would have seen that state. And we have folks who have asked us to, if I give you a backup box, or I give you a really fast network attached disk or something, can you make it so that the VM state every 1 second or even every 500 milliseconds is dumped without interrupting the workload at all, is dumped directly to my disk, so that in the event that the host disappears, I just remount my disk, which is pretty instant in their environments, and I'm good to go. And so we can do things like that. This is like an emergent behavior of if snapshots are this easy and this portable and you can synchronize this quickly, a really nice emergent behavior is that. Now, if you give us the 2-minute warning, well, you can see how many 2-minute warnings we could ignore.
Yeah.
If we're moving this. Now, this is a relatively small VM, and so that's something we should take into account. The number of CPUs actually doesn't change the migration time. So the CPUs being small doesn't actually do anything here. But as memory grows, that's kind of when we can run into some of those real world limits that we talked about, where the bandwidth isn't high enough, or I might need a little bit longer to migrate, et cetera, et cetera. You can see there's this little loader that shows up every 3 seconds. That loader, that amount of time that loader is on the screen is the end-to-end migration time, which again, we're only moving I think 2 or 3 gigs total of memory. We're moving the disk state and then the copy on write memory file. That's really all we're moving. So you can move it pretty quick. But I just that's kind of all you're seeing when these migrations are happening. So this test infrastructure is very important, obviously. So we can get these migrations to work as expected.